Hello everyone, we are going through the 2020 November Mathematics Paper 1. Diving right in for question 1.1. We are asked to solve for x. In solving for x, we have that x squared minus 6x is equal to 0. Now, we can already tell that x is our common factor, so we will take that out as our common factor. Open our bracket. What's going to be our other factor? It's going to be x minus 6. We equate all of that to 0. And now that you have your factors, you can then determine that your roots are either x is equal to 0 or x is equal, or let's do it step by step, x minus 6 is equal to 0, which tells you that x is equal to 6. Okay, those are your roots. 1.1.2, we are told that x squared plus 10x plus 8 is equal to 0, correct to 2 decimal places. Now, when you are told to correct to 2 decimal places, immediately what this should tell you in a solve for x question, or a question where you have a quadratic equation, this should immediately tell you to employ the use of the quadratic formula, where x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a, where a is equal to 1, b is equal to 10, and c is equal to 8. So what do you sub into your quadratic formula? You sub in x equal to minus, you put in your bracket, 10 plus or minus square root of 10 squared minus 4 multiplied by 1 multiplied by 8 all divided by 2 into 1. Okay, and now your answer will be equal to minus 10 plus or minus square root of 68 divided by 2. And when we decide to take this into 2 decimal places, we find that x is equal to negative 0.88, or x is equal minus 9.12. That is how you do 1.1.2. Moving on to 1.1.3, we have an inequality. Okay, we are told in 1.1.3 that 1 minus x plus 2 is less than 0. Okay, the nice thing is we already have our critical values. So a trick I like to use is I like to, in order to make this make a little bit more sense for me, I like to then substitute this inequality right here for an equal sign, right? So what I would do is I would say 1 minus x plus 2 is equal to 0, which tells me that x equals 1 or x equals minus 2, okay, which are our critical points. And then I come and draw my number line right there, my roots being minus 2 and 1, okay. And looking at our function, it will most likely have a frowny face, because if we multiply this out, we get x plus 2 minus x squared minus 2x. So since our coefficient of A is negative, this tells me that the graph will look something like this. Excuse my poor drawing. I'm very bad at drawing. So our graph will look something like that. So we are looking for values where this whole entire thing, this graph, right, which when expanded upon is essentially minus x squared minus x plus 2 is less than 0. Okay, so we're looking for places where this inequality right here, which is equivalent to this inequality, so we are looking for a situation where the inequality holds, right? So now when we look at our graph, when x is less than minus 2, right, our function value is below the graph. It's less than 0, right? We also notice that when x is greater than 1, our function value is still below the graph. Okay, so we have two options that we can use. Then our third option would then be the area where x is between minus 2 and 1. But when we look at this particular area, let me just use a different color for that. When we look at this particular area, we notice that our function value lies above the y equals 0 line. It lies above the x-axis, okay? So meaning we cannot use this this area right here as our answer, meaning this is not, the inequality is not satisfied in that area. Therefore, the final answer will thus be x must be less than minus 2 and or x must be greater than 1. Okay, now don't make a mistake and put in the equality there, because the initial question doesn't specify inequality. It asks for strictly less than 0. Therefore, your final answer should be strictly less than and strictly greater than, or strictly in between. It can never be equal to. Okay, moving on to 1.1.4, we have a question in third form where we are asked to solve for x. 1.1.4, we are asked to solve for x if the square root of x plus 18 is equal to x minus 2. Okay, now immediately, because this is a third equation, you know what you need to do is you need to square both sides, right? Now when you square both sides, the square root disappears on the left hand side, such that you have x plus 18 on the left hand side. On the right hand side, you essentially end up having something that looks like this. Expanding out our brackets, you have xx, that is x squared, x minus 2 and x, that's x minus 4x, that's x squared minus 4x, excuse me, and minus 2 multiplied by minus 2, that's plus 4. Okay, now taking everything on the left hand side over to the right hand side, we have 0 equals x squared minus 5x minus 14. Now writing this in a nice and neat way that we are used to, 5x minus 14 equals 0. Fine. Now we see that we need to factorize here because we have a quadratic equation, right? Now our quadratic equation requires that we have a factor of 14 and 1 that can give us a 5 in the middle, right? So we're going to have our x, right there equals 0. Now, what factors of 14 and 1 can give us a 5 in the middle there? It's obviously 7 and 2. So we're going to have x minus 7 on one side and x plus 2 on the other side, because our x right there is negative. So since our x there is negative, we have the bigger number being negative, okay? Or in this case, the smaller number. But then our final answer will thus be x equals minus 7, or x equals 7, or x equals minus 2. Now, because this is a question that is given in surd form, one of the answers is not going to hold. So what you do is you plug in one of the solutions, or either solutions, and see if what is on the left hand side is equal to what is on the right hand side. And after doing that, you have to reject one of the options, and in this case, the option that we have to reject, because it does not hold, is x equals minus 2. Just put that in your calculator, substitute in the value of x, and you will see that x is equal to minus 2 does not hold for this equation. Now, moving on to the next question, I'll just erase this. Wonderful. So now we are going to 1.2, the simultaneous equation. We are asked to solve simultaneously for x and for y if x plus y equals 3 and 2x squared plus 4xy minus y is equal to 15. Okay. Now, this already makes things easier for us, because we can immediately see that we need to isolate one of our variables on this side of the equation. Okay, on this equation, we need to isolate one of the variables, and let's choose x just to make, actually, let's choose y just to make things a little bit easy. Choosing y, we find that y is equal to 3 minus x. Let's label that equation 1. Let's label this equation 2. Now we will substitute equation 1 into equation 2. Okay, now doing that, we will have 2x squared plus 4x into 3 minus x, because remember y is equal to 3 minus x, minus open bracket 3 minus x is equal to 15. Do not forget your brackets. They are very important because they preserve the order of the algebra. Okay, now moving forward, we find that 2x squared plus 4x multiplied by 3, that will give us 12x. 4x multiplied by 3 will give us a 12x. 4x multiplied by negative x will give us minus 4x squared. Moving on, we will have minus 3. Negative multiplied into negative x will be plus x, which is equal to 15. Now, we will take this 15 and put it on the left-hand side and equate all of that to 0. Just so that we can make life a little bit easier. Now, eliminating like terms, we have the 2 and the minus 4 there. That will give us minus 2x squared. Taking the 12x and the x right there will be plus 13x. And finally, eliminating minus 3 and minus 15 will give us minus 18 equal to 0. So because we have a negative coefficient of x squared here and we have a 0 on the side, we can just multiply both sides of our equation by -1 in order to turn this coefficient right here into a positive number. So the way we're going to do that is we're going to take 2x squared minus 13x plus 18 and equate that to 0, because we've multiplied by -1 on the left hand side, and we've multiplied by -1 on the right hand side, and you know any number multiplied by 0 is equal to 0. So now we are looking for factors of 18 and 2 that can give us a 13 in the middle. But we know that 18 is the product of 9 and 2, so we will have 2x minus 9 into x minus 2, which gives us a 0 there. Therefore, your final answer will be x equals to 9 over 2, or x is equal to 2. Now, what we're going to do is we're going to take these two solutions and substitute them into equation 1. Okay, we're going to take whatever we found for x and substitute it into equation 1. So we will find that y is thus equal to 3 minus 9 over 2, because we substituted in that x is equals to 9 over 2, which tells us that y is equals to 3 multiplied by 2, that's 6 minus 9, that's 3, all over 2, that's minus 3 over 2, or y is equal to 3 minus 2, which is equal to 1. Therefore, your final coordinates will be x 9 over 2, y minus 3 over 2, or x2, y 1. And finally, that is the end of our simultaneous equation. That is the solution. Moving on to question 1.3. So question 1.3 tells us that if n is the largest integer for which the number n to the power 200 is less than 5 to the power 300, determine the value of n. Now, we are told that n to the power 200 is less than 5 to the power 300. Okay, now looking at this, what can we do in order to make sure that our bases have the same power? What is the common factor between 200 and 300? Well, the only number that is common between 200 and 300 is the number 100, right? So we can take out a number we can factorize this 200 here to give us a common factor, with some number factorized here to give us another common factor. So I'll show you what I mean. We will factorize n to the power 2 all to the power 100, and we will say it is less than 5 to the power 3 n to the power all to the power 100, because remember the laws of exponents that tell you that a to the power m is equal to let's call that b. A to the power b in brackets all to the power m is equals to a to the power b times m. Okay, this is the law of exponents that we are using in order to solve this question right here, to solve this inequality. Now, seeing as we have same power, right, the same power factor, we can take the 100th root on both sides of our inequality. Okay, we can take okay, let me just write that out nicer. We have established that n squared to the power 100 is less than 5 cubed to the power 100. Now what we can do is we can take the 100th root of n squared to the power 100 and make it less than the 100th root of 5 to the power 3 all to the power 100. That leaves us with n squared is less than 5 to the power 3, which tells you that n squared is less than 125. And finally, the maximum value of n is 11 because n is less than 11 when you take the square root of both sides. Max value of n is 11. There we go. And now moving on to question 2. Question 2. Now, of course, it is important to remember that when you take the square root of 125, you find some number with decimals. You will find 0.18, some of you will find 0.19, some of you will find 0.16. But when you round this number off to the nearest integer, it gives you that this is 11. Okay, when you round it off to the nearest whole number, it gives you that the maximum value of n can be 11. Now moving on to our sequences and series. Nice thing is we have a sequence on in this case for question 2.1. We are told that 7x, y, and minus 11 is an arithmetic sequence. Determine the values of x and y. Okay. Now, in trying to determine the values of x and y, we have a formula that we can use. We know that the first value of our sequence is given by a, right? And then from a, we know that a plus 3d is equal to minus 11. Okay, which is the fourth term in our sequence, right? Now, this tells us that since a is 7 is equals to 11, this tells us that d is equal to minus 6. Now, remember, d is the common difference, right? D is the common difference. This is the formula for finding the common difference, okay? So, since d is equal to 6, we can then determine that x is equal to a plus d, which is equal to 7 plus minus 6, which is equal to 1. And we can therefore also determine that y is equal to a plus 2d, which is equal to 7 plus 2 into minus 6, and that is negative 5. Okay, moving on to question 2.2.1. Okay, let me just erase this. Question 2.2.1. Given the quadratic number pattern, minus 3, 6, 27, 60, moving on, okay. Now, we have a quadratic pattern. We must determine the general term of the pattern. So, for quadratic pattern, the first thing that we need to do is we need to determine the second difference and the first difference, okay. So, we can do that by taking 6 minus negative 3, and 6 minus negative 3 is 9. We know that we will also have a second difference, a common second difference, okay? So that is what we're searching for. So the first difference here will be 27 minus 6, that will be 21. 60 minus 27 will be 33. And then the second difference, the second common difference, the common difference here will be 21 minus 9, that will be 12, and 33 minus 21, which will also be 12. Okay, so now 2.2.2, determine the general term of the pattern in the form Tn is equal to an squared plus bn plus c. Now, our formula for finding the general terms tells us that we have to start with the second difference, right? And we know that the second difference formula is given by 2a is equal to 12, which gives us a is equal to 6, okay? Now, from there, we will take the first term in the sequence down here, right? And equate that to 3a plus b. And then from there, because I remember this is our first difference. This is our first difference, and this is how you find your first difference. Now, a we found to be 6, 3 into 6, plus b equals to 9. Now, this will be 18 equals to that. Thus, b equals to minus 9. And finally, for the first term in our sequence, we know we can find that by using a plus b plus c equal to the first term in our sequence. Our value of a is 6. Our value of b is minus 9. We have no idea what c is. We can finally conclude that c is equal to 0. Therefore, our general term is given by a by 6n squared minus 9n, because why? C is equal to 0. 2.2.2. Sorry, this was 2.2.1. And now, for 2.2.2, we are asked to calculate the 50th term of the pattern. So for the 50th term, we know n is equal to 50. This tells us that T50 is equals to 6 into 50 squared minus 9 into 50. And that will be 14,550. 2.2.3, show that the sum of the first n differences of this pattern can be given by Sn is equal to 6n plus 3n, 6n squared plus 3n. Okay, so the sum of the first n differences. Okay, now the first differences are given by the sequence 9, 21, and 13. Okay, so that's 9, 21, and 33. 33 and all of that. Now, our formula for finding the we know that the first term in the sequence a is equal to 9, right? And we know that the difference between all of these terms d is equal to 12. Okay, so our formula for finding the term of first differences, the general term given by the first differences, by the sequence of first differences, is Sn is equal to n over 2 into 2a plus n minus 1 multiplied by the difference. Now this will be n over 2 into 9 plus n minus 1 multiplied by 12. That will be n over 2 into 18 plus 12n minus 12. And finally, we have n over 2, 12n plus 6, which simplifies to 6n squared plus 3n. Now we were asked to find it in the form there that is given, 6n squared plus 3n, and there is our 6n squared plus 3n. Moving forward, how many consecutive first differences were added to the first term of the quadratic pattern in order to obtain a term in the quadratic number that has a pattern, and the quadratic number pattern that has a value of 21,060. Now, this question is asking us how many consecutive first differences were added to the first term of the quadratic number pattern, okay? Now, the first thing we're going to do is we're going to come and say, that's 2.2.4. We're going to come and say minus 3 plus Sn is equal to 21,060, okay? Now, then Sn will be 21,063 because this minus 3 moves on to the other side. And our Sn we substitute in 6n squared plus 3n. And we bring this to the left-hand side. Well, that will be minus 21,063 equate to 0. Divide through by 3, and that will give us 2n squared plus n minus 7,021 equals 0. Then we take our quadratic formula, where n is equals to minus b plus minus square root of b squared minus 4ac all over 2a, which is equal to our b is 1 minus 1 plus minus square root of 1 squared minus 4 into 2 into minus 7,021, close the bracket, over 2 into 2. Then finally we have that n is equal to 59, or n is equals to minus 119 over 2. But we know that our n has essentially has to be a whole number, right? It has to be a whole number. So since our n has to be a whole number, we can reject this this option. Now, here is a second easier way to do it. I realize that this formula might be a bit confusing, especially because of this minus 3. You might not understand where it comes from. So to give you just an easier way to do it, just equate the term in the sequence that they want to the general term, right? So, because remember, the question asks us how many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060. So this is essentially a trick question. This is just trying to ask you which term in the sequence has a value of 21,060, right? So the term in the sequence that has, and also remember that they're looking for how many consecutive first differences were added to the first term, right? So meaning the first thing that we're doing, we're looking for the value of n, for which Tn is equals to 21,060. And then the second thing that we're looking for is how many consecutive first differences were added to the first term. So it's going to be whatever n is minus 1, okay? So working it out, let's work it out. We know our Tn is 6n squared minus 9n. We'll just bring this over to the left-hand side real quick and write it as minus 21,060, which is equal to 0, okay? Dividing through by 3, we find 2n squared minus 3n minus 7020, which is 0. And plugging this into our quadratic formula, we find that n equals 60, right? Now, but remember that we are looking for how many consecutive first differences were added to the first term. So here we are going to conclude that 59 first differences must be added, because remember what I told you in the beginning. I told you that whatever number of first differences must be added to the first term to give us this term will be n minus 1. Now n minus 1 is 59. Okay, so yeah, that is essentially the quickest and easiest way to do it. Oh, we're done with question 3. Okay, let me just erase that. And that has been erased. We're done with question 2. Now moving on to question 3. Question 3, we are asked to prove that the sum to infinity of k equals to 1. The sum to infinity from k equals to 1 of 4.3 to the power 2 minus k is a convergent geometric series. Show all calculations. Now, 3.1, we can write out k equals to 1 up to infinity of 4.3 to the power 2 minus k is equal to, the first term will be 4.3 to the power 2 minus 1 plus 4.3 to the power 2 minus 2 plus 4.3 to the power 2 minus 3 plus moving forward all the way up to 4.3 to the power 2 minus k, right? Now, because we are told that this is a geometric, we are told that this is a geometric series, what we need to do then is we need to write out what these are, right? Now, this will be, the first one will be 12, the second term will be 4, the third term will be 4 over 3, plus all of that. Now, because this is a geometric series, we know that we must have a common ratio, and the common ratio is given by the second term divided by the first term, which is 4 over 12, right? Now, 4 over 12 is equal to 1 over 3. And we know that in order for a series to be convergent, the common ratio has to be between minus 1 and 1. And indeed, our R is between minus 1 and 1. 1 over 3 and 1. Series is convergent. Quite simple. Okay, now we are told that if the sum to infinity k starting from p of 4.3 to the power 2 minus k is equal to 2.9, 2 over 9, determine the value of p. So 3.2, we are going to start out by writing our sum, k equals p, k equals p up to infinity of 4.3 to the power 2 minus k. We're going to start off with 4.3 to the power 2 minus p, okay, plus 4.3 to the power 1 minus p, plus 4.3 to the power minus p, plus all of that. Okay, so our first term in the series A is equals to 4.3 to the power 2 minus p. we know that the common ratio is 1 over 3 because we determined that in the previous question, right? Now, the sum to infinity is given by a over 1 minus r. And we were told in the beginning of our question that our sum to infinity is equal to 2 over 9, which is equal to a is 4.3 to the power 2 minus p all over 1 minus 1 over 3. Working that all out will give us that 4.3 to the power 2 minus p is equal to 4 over 27. Okay. Now, seeing as this is 4 to the power 27, we can then... Oh, this is a multiplication. This is not a point. This is a multiplication. Please be careful of that. This is a multiplication. We will find that if we divide through by 4, 3 to the power 2 minus p is equal to 1 over 3 to the power 3, because remember 3 to the power 3 equals 27. Now, because we have the same base, because 2 minus p is equals to 3 to the minus 3, we can equate exponents to say 2 minus p is equals to minus 3, and finally p is equal to 5. And you get your 8 marks just like that. And now moving on to question 4. We are given that h of x is equal to minus 3 over x minus 1 all plus 2. Now 4.1.1, we are asked to write down the asymptotes of h. Now immediately you can tell that x equals to 1 and y equals 2. Those are our asymptotes. 4.1.2, determine the equation of the axis of symmetry of h that has a negative gradient. Okay, now we know that our equation of the axis of symmetry will have y being equal to mx plus c. Now, because we know that this is an axis of symmetry, our gradient will be equal to minus 1, right? Because it's an axis of symmetry that has a negative gradient, which is why our gradient is negative, right? But always remember that an axis of symmetry has a gradient of 1. Now, an axis of symmetry also passes through the point at which the asymptotes intersect, okay? So meaning on our graph, if my asymptote is x is equal to 1 and y is equal to 2, my axis of symmetry passes through the point of intersection there, right? So that means I can just plug in those values of the asymptote, where y is equals to 2 is equals to minus into 1 plus c, which tells me c is equals to 3. Therefore, the equation of my axis of symmetry will be y is equal to minus x plus 3. And now 4.1.3 is asking us to sketch the graph of h, showing all asymptotes and intercepts with the axis. 4.1.3. Once again, please excuse my atrociously horrible drawings. That is our axis line there. That will be our y-axis. That will be our x-axis. And this will be our first asymptote at 1. And this will be our second asymptote at 2. There is where they intersect. Okay. And now our intercepts. The first intercept is found where, the y-intercept is found when x equals to 0, so that will be minus 3 plus 2. And sorry, that will be positive 3 plus 2, that will be 5. Therefore, meaning our graph will be passing through 5 like that, moving up. And our x-intercept will be at the point where y is equals to 0. So if y is equals to 0, that tells me that minus 3 is equals to minus 2 into x minus 1. Therefore, x equals 3 over 2 plus 1, and that is 5 over 2. That tells me that my graph passes through 5 over 2 like that. And that is the graph, ladies and gentlemen. Moving on to 4.2. 4.2 tells us the graph's f at x is equals to 1 over 2 into x plus 5 squared minus 8x, and g at x equals to 1 over 2x plus 9 over 2 are sketched below. A is the turning point of f. Here's our turning point there, and we can immediately tell that our turning point occurs at a point where that is the y-intercept. Okay, we already know that is the y-intercept of our graph. The axis of symmetry of f intersects the x-axis at E and the line G at D. Okay, the axis of symmetry of f intersects the x-axis at E and the line G at D, which is the point MN. Now, C is the y-intercept of f and G. Okay, so now we are asked to calculate or write down the coordinates of A. Now, the coordinates of A, because we know that A is the y-intercept. For the y-intercept, let's write that down, 4.2.1. For the y-intercept, we know that x must be 0. Therefore, f at 0 will be equal to 1 over 2 into 0. 1 over 2 into 0 plus 5 squared minus 8. This is equal to 25 over 2 minus 8. That will be 25 minus 16. 25 minus 16, which is equal to coordinates of A. What is going on? Okay. So for the coordinates of A, oh, no. That is not an intercept. Oh my goodness. No, that is not an intercept. Please excuse me for that atrocious error in judgment. I did not notice that this is the y-intercept right over there. So we are told to find the coordinates of A. So for the coordinates of that, the coordinates of the turning point, if you are given a function in the form y is equals to a x plus b squared plus c, okay, if you are given an equation in this form, the turning point is given by b and c, okay? The coordinate is always given by b and c. So in this case, we will have that x equals minus 5 and y is equal to minus 8. Those are the coordinates of our turning point, because when you look at where it is on the thingy, on the Cartesian plane, it exists on the third quadrant. On the third quadrant, this is negative and that is also negative. So hence why we have x equals minus 5 and y equals minus 8. 4.2.2, write down the range of f. Now f is a hyperbolic graph, meaning its range is any point on the y-axis that lies either above the x-axis or below, above the turning point or below the turning point. Now, because in this case, our graph is frowning up, is smiling, okay, yes, because our graph is smiling, it means that the range of f will be any point starting from the turning point all the way up to positive infinity. Therefore, we know that y must be an element of minus 8, up to infinity. Now, notice here I used the square bracket here to show you that y starts by taking on a value of minus 8 at the turning point, okay? It's inclusive, okay? Now, another way to write this would be y is greater than or equal to minus 8. Because if y is greater than or equal to minus 8, it is not restricted in the value that it can take. It can take up any value between minus 8 and positive infinity. But it cannot go below the value minus 8. Wonderful. So 4.2.3, we are asked to calculate the values of m and n, okay? Now, we already know that m is equal to minus 5 because we established in the first question that x is equal to minus 5. And since a and d are collinear on the x-plane, we know that they share a common value of minus 5, right? Now, remember, the point D is also a point on the line G of x, right? Now, we can therefore say n is equals to G at the point x equals to 5. And at the point equals to 5, G is 1 over 2. Sorry, at the point x equals to minus 5. 1 over 2 into minus 5 plus 9 over 2. And that is equal to 2. Therefore, we know n is equal to minus 5 and 2. Easy enough. 4.2.4, we are asked to calculate the area of O, C, D, E. Okay, so we are asked to calculate this area right here. Now, calculating this area right here requires us to use a combination of methods, right? You could either use the area of a trapezium combined with the area of a triangle. Okay, so what I mean is you could first calculate the area of this triangle, right? And then calculate the area of this triangle. And after calculating the area of these two triangles, you would substitute the area of the green triangle from the area of the purple triangle. Okay, that is the first method you could use. The second method you could use is you could take the area of this triangle right here, because there is a triangle there. Okay, you could take the area of this triangle right here and add it to the area of this rectangle right there. Okay. And finally, the last method is you could use the area of a trapezium, where you just take the area of this entire trapezium there. Okay, so if we take the area of the trapezium, using the area of the trapezium, we know that area of a trapezium is given by 1/2 of two parallel sides, right? 1/2 of the sum of two parallel sides. And our parallel sides are OC and DE, right? So that's going to be DE plus OC multiplied by the base, okay? The base of the trapezium multiplied by the base of the trapezium, which is OE in this case. O multiplied by OE. Okay, so this is DE plus OC. Now for DE is the distance between here and there, meaning which means it is the value of y, that is 2. So that's going to be 1/2 into 2 plus OC. OC is the distance between here and there, and the distance between here and there is the value of the y-intercept of the line G at x, right? And the y-intercept of G at x is 9/2 multiplied by OE. OE is the distance from O all the way to E, and we know that the coordinate of A is -5, therefore we multiply by 5. Thus that is equal to 16.25, and that would be the area of your trapezium. Okay. Another method you could use, okay, I'm going to show you the method where you take the area of this triangle right here, right, and you add it to the area of this rectangle right there. Now the area of the rectangle, let's start with the area of the rectangle. Okay, let's call this option 2, area of the rectangle. So the area of the rectangle is equals to the base multiplied by the height, right? And looking at our rectangle, here is our base. Our base has a length OE. OE we've already established is equal to 5, because remember the coordinate of the value of M is -5. Therefore we know that the base is equal to 5 multiplied by our height. Our height will be, because remember our rectangle is like that, our height will be this a length right here, DE, and our length DE we've established is 2, and that is equal to 10, right? And going on to the area of the triangle, which is equal to half the base times the height. Now our triangle has a base that is equal to the base of our rectangle, and we've established that that number is 5 multiplied by the height of the triangle. Now the height of the triangle will be the distance coming from this point right here up to that point right there. Okay, so we know that this line right here is the line y equals to 2, okay, and we know that the coordinates of C are given by let's say 0, yes, are given by 0 and 9/2. So this distance between C, this orange distance right here, will be given by 9/2 minus 2. So we know that 9/2 minus 2 will be 9 minus 4/2, which is equal to 5/2. Therefore, our height will be 5/2. Sorry, I'll use a different color for that. 5 over 2. Therefore, this is 25 over 4. Finally, area of our trapezium is equals to 10 plus 25 over 4, and that is 16.25. That is the final answer. Now moving on, determine the equation of the inverse of g in the form y is equal to whatever the inverse of g will be. Okay, so in order to determine the inverse of g, that's 4.2.5. In order to determine the inverse of g, we're going to first write down the equation of g, and the equation of g tells us that y is equals to 1 over 2x plus 9 over 2. Now, the first thing that we need to do in order to determine the inverse is we need to interchange x and y, meaning wherever we see a y, we write down an x, and wherever we see an x, we write down a y. Okay? Now, what we need to do here is we need to rearrange it so that y then becomes the subject of the formula. So from here, we're going to have 2x is equals to y plus 9. Therefore, y is equals to 2x minus 9. And that will be the equation of our inverse. Let's write this as y inverse. Y inverse. But then, okay, let's write this finally. Let's just write g inverse is given by that instead of writing y inverse there. Yeah, g inverse is given by that. Finally, 4.2.6. 4.2.6 is asking us if h at x is given by the inverse of x plus k, which is a tangent to f, determine the coordinates of the point of contact between h and f. All right. Now, we know that f at x is given by 1 over 2x plus 5 squared minus 8. And when we write this out completely, this will be 1 over 2 into x squared plus 10x plus 25 minus 8, 1 over 2x squared plus 5x plus 9 over 2. This is what our f at x looks like. And we know that the tangent, right, because remember, h at x is tangent to f. The tangent of f prime at x is given by x squared plus 5. Sorry, that's x plus 5 plus x plus 5, right? We are told that the tangent is that. We find that the tangent is that. Now, we are also told that h at x is equal to the inverse plus k. So now our inverse will be 2x minus 9 plus k. Okay. Now, remember that we are told that h at x being this is tangent to f. Now, if h at x is tangent to f, then we can determine that x plus 5, right, which is the gradient of the tangent, remember, the first derivative is the gradient of the tangent. It doesn't give you the equation of the tangent, rather, but it gives you the gradient of the tangent. And the gradient of this tangent is 2. Therefore, x plus 5 equals to 2. X equals minus 3. then if x equals to minus 3, substituting this into any one of our values, we find that into any one of our formulas, f at x or h at x, even, but rather substitute it into f at x, you find that y is equal to minus 6. And that is the point of intersection where our graphs meet, where f at x is equal to h at x at the point minus 3 and minus 6. And there you go. Another way to do it is you could equate these two and try to solve. But equating and trying to solve would be a bit of a tedious exercise because you don't know the value of k. So this method would be the best to go with in this situation. Moving on to question 5. Question 5, we are told that the graph of f at x is equal to 3 to the minus x sketched below. A is the y-intercept, and B is the point of intersection of f, and the line y equals 9. Okay, write down the coordinates of A. Immediately, you can tell that the coordinates of A is equal to 1, is 0 and 1, because 5.1, A is the y-intercept. So if A is the y-intercept, that means f at 0 is equals to 3 to the minus 0, that will be 1. Therefore, A will be 0 and 1. 5.2, determine the coordinates of B. B is the line where f at x is equal to 9, right? Therefore, 3 to the minus x is equal to 3 to the power 2. And finally, x equals minus 2. Which tells you that the coordinates of B are minus 2 and 9. Laws of exponents, same basis, equate exponents. Okay. 5.3, write down the domain. Now, the domain of x, right? The domain of x will be x as an element of 0 to infinity, or x is greater than 0. Because if x now becomes less than 0, yeah, that is the answer. X must be greater than 0. Describe the transformation from f to h at x. Okay, so the transformation that takes place, 5.4, will be h at x is equals to 27 into 3 to the power minus x, right, which is equals to 3 to the power minus x minus 3, because remember this has a base 3 to the power 3. And thus this tells you that f has shifted 3 units to the right, because remember, if this is positive, then it means that x has shifted 3 units to the left. And finally, 5.5, determine the value of x for which h at x is less than 1. H at x less than 1. We will have that 27 over 3 to the power x. 27 to the power 3x is equal to is less than 1, which tells us that 27 is less than 3 to the power x, and 3 to the power 3 is less than 3 to the power x, and finally x must be greater than 3. And that is it for question 5. Thank you for joining me on this video. I will see you next time.